Hi, my name is Benjamin Wilson. This is my video lab report for Lab 2 Lines of Charge for Physics 2212. As an introduction, the purpose of this lab was to construct a computational model of the line charge based around the tapes featured in the charge tape experiment to compare to the net charges calculated for a piece of tape in each respective model. The fundamental physical principles that were featured in this lab can be shown below. The model that we ultimately came to construct by the end of this lab can be seen illustrated to the left. It represents the top piece of tape with the red line, the bottom piece of tape with the blue line. And as you can see, each piece of tape is broken up into smaller segments to represent a total in number of point charges distributed along the length of each piece of tape. The green arrows represent the net electric field experienced by each point charge on the top piece of tape, induced by the superposition of the electric fields induced by each individual point charge from the bottom piece of tape, and then the net electric force was calculated using that, as represented by the white arrow, whereas the net gravitational force is represented by the yellow arrow. Some simplifying assumptions we made in this experiment, as in the previous experiment, were to ignore air resistance, and that each piece of tape made had about the same amount of charge, evenly distributed along the length of the tape. The results of this lab were that the magnitude of charge in a piece of tape was 22.14596 e to the negative 9 coulombs, which was different from the previously approximated net charge on a single piece of tape with the original point charge model. However, the computation model was more accurate. Again, this is the previous experiment that this lab is based around. And this is the data and calculations made in the previous experiment. Again, the charge calculated was 9.3 e to the negative 9 coulombs, which is different from what was calculated in this lab, and we'll delve into that further as we progress throughout the lab report. Starting to look at the code, we defined some of the physical constants that we need in this computation model, gravitational acceleration, as well as the constant in Coulomb's law. This is the mass of the individual piece of tape taken from the previous experiment, and then this is the net charge calculated for an individual piece of tape using this computation model. This is a function defined for the purpose of calculating the E field, electric field induced by an individual point charge at a given observation location. And then this is a function used for the purpose of turning each piece of tape into line charges, and that were divided up into different segments in point charges. Here, this nested for loop, this for loop nested in a for loop, was used for the purpose of iterating through each point charge in the bottom piece of tape and calculating the electric field for each of these point charges at each of the point charges in the top piece of tape in order to calculate the overall net electric field experienced by each point charge in the top piece of tape, and using that to ultimately calculate the overall net force experienced by the top piece of tape induced by the bottom piece of tape. And then finally, this last section of code was used to create an arrow that represented that net electric force, an arrow that represented the net gravitational force on the top piece of tape, and then print the magnitude of electric force as well as the magnitude of gravitational force calculated in the previous code. Comparing the two computation models, we can see that the one on the right is the line charge model and is far more comprehensive than the one on the left being the point charge model. However, despite the greater accuracy likely displayed by the line charge model, there's still potential errors that are present in both models. With line charge model specifically, the number of point charges used to calculate and approximate the net charge on a piece of tape is still finite as opposed to infinite. So it's still not as accurate as it could be. And also, the overall forces in the surroundings that we considered to be operating on the system, being the top piece of tape, was simplified and doesn't include certain factors that definitely would affect the outcome, such as air resistance, as we mentioned before. Additional questions. If you had modeled each of your tapes with single point charge like in the previous lab, compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. Effectively, this is just having me compare the approximation of the net charge on a piece of tape that I calculated with a point charge model in the previous experiment, and the approximation that I calculated in this lab using the line charge model. And the discrepancy between the two can be explained by the fact that the line charge model is more likely to be closer to the real value, seeing as it is more accurately models the realized superposition of electric fields for multiple point charges, as opposed to just making the simplified assumption that all electric fields produced by the deficiency of electrons in the tapes can be represented by just one point charge in the center of both pieces of tape. Thank you.